3.3 Properties of Logarithms. What we should learn: rewriting logarithms with different bases, using property logarithms to evaluate and rewrite logical expressions, using property logarithms to expand or condense logarithms, and using logarithms in real life problems. So the change of base form is just a way to rewrite logs or natural logs into a way that we might find it easier for us to use. A lot of people use it for calculators, so not all calculators have every base, but you can use it for lots of different tricks. So all it is literally just separating it. Whatever the base is, I like to say goes to the basement, and then where the top number is goes to the top. So like here and here, right? And you could change it to any base you want. As long as you keep it consistent, it's all good. So like here, you want us to rewrite the base, we'll do it with the common log, which is the base 10. So you're just going to write this as log base 10 of 25. The base goes in the basement, log base 10 of 4. And you just rewrote that log as something equal. And this is something we can put in our calculator without much, but you put into like a scientific calculator, because scientific calculators don't have any bases besides 10. So that you would do it that way. But if you wanted to, you could also change that to like log base 3 of 25 and log base 3 of 4. It doesn't matter. As long as the bases are the same, you could change it to any base you want. So this one would be, again, we're going to do common log, so 10. So this one, put log 12 on top and log 2 on the bottom. If you notice, I didn't put the base 10 because that's the common log. You don't need to put a 10. If you don't have a base, it's 10. We're going to do the same thing using natural logs. So just going to go, boom, log base. What am I doing? Natural log. Natural log of 25 over natural log of 4. Remember, the base goes to the bottom. I wrote log base C, and I was like, wait, that's just a natural log. So like that. Same thing here. I've always been a fan of the natural log because it's one less letter to write. So it's always held a good place in my heart. So right, top number goes on top, base goes in the basement. So we talked about some properties of logs last video, but now we're going to talk about some more like properties of between logs. So first of all, if you have a log or a natural log and they're being multiplied on the inside, like you get like log 3x, you could write it as addition. And that's because, remember, logs are just inverses of exponential functions. So if I give you an exponential function and I multiply them like this, right? What do? I add the powers. Right? And we're doing the inverse of that. If we're multiplying, it's the same thing as adding logs. So it's an important result. Multiplication is addition. If you have two logs being multiplied in the same thing here, you can separate them out as multiplication. Now keep in mind, that's not saying this. It's not saying log of 3 times log of 2. That is not equal to log of 2 plus 3. It's not what that's saying. Right? But if they're inside like this, you can separate them. Same thing with dividing, and for the exact same reason. If you divide, you subtract. And the power property is one of the big ones. If I give you a log like this, let's say 10 2 to the x, the power property says you could bring this power to the front. So it becomes x log base 10 of 2. We're going to use that property a lot. We're going to use all these properties a lot, but that's probably one of the ones you can use this all the time. So power property, you could bring that power to the front. So let's use some property logs. We want to write this in terms of 2 and 3. So it's the only way we can use is 2 and 3. So this first one here, well, I know 6 is 2 times 3, so I could write 6 as 2 times 3. Then using property logs, multiplication like this, it's the same thing as addition. So natural log of 2 plus the natural log of 3. And there we go. You just rewrote natural log 6 like this. This one, the top is easy. It's natural log of 2. Got it. The bottom, I need to write that as a 3 somehow. Well, 27 is the same thing as 3 cubed. So I'm going to do this first. Then I'm going to use my property, divide means subtract. So again, we're going to do separate logs, natural log of 2 minus natural log of 3 cubed. Right? Top goes on top, subtract by the bottom. Anything on the bottom is subtracted. And then I'm going to use the power property, move that 3 to the front. So I'm going to get natural log of 2 minus 3 natural log of 3. That's it rewritten. On this one, they want to verify that this guy is equal to that guy. Well, let's look at this one first. Now, this is a fraction bar. Remember how we could fix that? Flipping a fraction means you take it to the power of -1. So I just flipped it, right? So I flipped it, got a power of -1. Now use the power property, move this to the front. The two negatives cancel, you just get this, which is equal to that side. right? So I flipped it, got a -1 power, moved to the front, 2 negatives make a positive, and now they match. Rewriting log expression. So we just want to do this. We want to use these rules, right? So natural log of AB is the natural log of A plus the natural log of B. When you divide natural log of A over B, keep in mind the top is positive, the bottom is negative. So here we just want to rewrite it. So we're going to expand this. So all these things being multiplied are going to get a plus sign. So it's going to be log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Like that, right? So I just separate them all because they're all being multiplied, and multiplication is addition. Almost done. There's a power here we can move to the front. So really I should have log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Just scrunch it in down there. Sorry about that. The next one, so I can't do anything with the square root, but I can rewrite the square root. That's the same thing as saying this. 3x minus 5 to the 1/2 power over 7. Now divide works very similarly. Anything on top is going to be a positive because you're adding. Anything on the bottom is going to be a negative because you're subtracting. So we're going to first start off with natural log of 3x minus 5 to the 1/2. Now again, this is a positive. I don't write plus here because it's the first thing, but it is a positive value. The thing on the denominator is a minus. So we're going to subtract natural log of 7. Almost done. You're still going to move the powers to the front. So 1/2 natural log of 3x minus 5 minus natural log of 7. So that's rewriting in log expression. This one's going the opposite way. We're going to condense the log expression. So we want to bring them all together. So first, it's like over operations. So you're not going to add first. You're going to do the power first. It's like multiplication. So we got to do that first. So I'm going to bring this 1/2 up to the front here. And bring the 3 up to the front there. So I'm going to get this. Log, I'm going to not put the 10 because it's common log. So 1/2 plus log x plus 1 to the 3rd. Just like that. And if I want to be really cool, x to the 1/2 is the same thing as square root of x. So I'm just going to use that. Plus means multiply. So we're going to combine these one more time. Log square root of x. So I'm cool. And then x plus 1 to the 3rd. So that's this guy written all together. B, natural log doesn't change, same rules. First, let's move this guy to the front. So natural log of x plus 2 squared minus natural log of x. Now I got a subtraction, right? Remember, subtraction is divide. So this is the key thing. It's only one log. You're writing it as one log. So natural log, put a divide sign. What goes on top and what goes on the bottom? On top is a positive thing. This is positive. So x plus 2 squared. On the bottom is a negative thing, x. And like that. The most common mistake is people they'll just do this. That's wrong. It should only be one log. When you condense it, you only get one log. Same thing we got here. So this one has all this mess. I'm going to work outer operation, work the inside first. So this is a plus sign, so we're going to multiply. So I'm going to have a 1/3 on the outside, and I'm going to have log 2 x times x minus 4. Like that. Just for the sake of the 1/3, let me simplify this real quick. Distribute, I'm going to get 1/3 log base 2 of x squared minus 4x. That's all in parentheses. Then let's just move the 1/3 up. So you get log base 2 of x squared minus 4x to the 1/3. And that's fine. If you want to try to make it a little nicer, you could probably write it like this. The cube root of x squared minus 4x. But I see both as equal. And that's it.